Welcome to this video tutorial on quadratic systems of equations. So look at the system of equations we have on the board. The first thing we will want to do is get each of them into a graphable form. For the quadratic, that means we're going to take the 2x squared over to the right hand side, and it will become positive when we subtract it from both sides. But then we also need to complete the square, so I'm going to leave a little space. Remember, we factor out the number attached to the x squared from both of the variable terms. So 4 divided by a negative 2 leaves us with a negative 2, and this plus 5 is off on the side. This is just completing the square, so half of the negative 2 is a negative 1. When we square a negative 1, we get positive 1, but be careful, because what we have really included in this expression is a negative 2. To balance that off, we need to add 2, and that means we'll have a plus 7 on the side. So there is the equation of our parabola. Notice it will have a vertex at 1 comma 7. It opens down, and we multiply by 2. The other equation that we have is this line right here, and when we subtract x from both sides, the equation of the line is y is equal to a negative x plus 3. So now we go to our grid, keeping in mind where we need everything to be. I'm going to put the vertical axis about so, and we'll put, knowing that we have to go up 7, put the horizontal axis about there. Please remember to label your axes. So horizontal is the x-axis, vertical is the y-axis. And now let's plot these two graphs. So first I'm going to start at 1 comma 7, 2, 3, 4, 5, 6, 7, count carefully. And then what we're going to do is we go over 1 down 2 because we're multiplying by 2. And then we go over 2. Normally it would be down 4, but now we're going to go down 5, 6, 7, 8. And 8. And we'll sketch that. Try your best to sketch it in a smooth way. It shouldn't look like pieces of lines. It should look fairly smooth when you draw that in. And I'm going to draw it in over here as well. A little bit trickier on this program, but there it is. And now we have to draw the line. Y equals negative x plus 3, which means we start up 3. And we could either go left 1, up 1, or we could go right 1, down 1 in order to plot our points. When you go to graph it, make sure you draw it as a straight line. So here, take our straight line, use a ruler if you need to. Notice how we're putting the arrows on the ends because the lines and the parabola go forever. Make sure you indicate that. Uh-oh. We do not have exact intersection spots. We cannot use our hand-drawn graph to identify the value of x and the value of y in either of these two locations. So graphing by hand, that's as far as we get. We've got the picture, and we'll leave that. But now let's turn our attention to our calculator to try to finish this off, to figure out what those values actually are. So when we go to figure out what the values actually are, we go into our y equals, and we're going to type the equations as they were. So on the one hand, I've got negative 2x squared plus 4x plus 5. And for the other, we have negative x plus 3. Now when we look at our graph, it looks like the standard window we've been using, x min negative 10, x max 10, y min negative 10, y max 10, should probably work as well. What we could do in this problem though is we could make the x's a little bit more restricted. So we could go from like negative 3 out to 5 and we should be pretty good. That catches the gist of the graph. So after we've done our window, we're going to hit graph, and there's our picture. Now if we want to solve for this intersection over here, we go into second trace, where we calculate. Item number 5 is intersect. Hit enter on the first curve, hit enter on the second curve, and when you take a guess, you want to get this little cursor near where the intersection point is. You can either scroll it by clicking the left arrow, or you could type in a value of x. For example, I can just type negative 2. Notice my calculator says that's my guess. Hit enter, and it actually does the calculation. And now that it's done that calculation for us, copy paste that in here. Notice at least two decimal places correctly rounded, please. Negative 0.35, 3.35. Look at the point. That seems about where it fell on our hand-drawn graph. But now we actually want to go back to our calculator. Now we're going back to our calculator to find the other intersection point. So graph, hit graph first. Then second, trace to calculate. Option 5 is an intersect. Hit enter, hit enter. Guess the second one. I'm going to guess x equals positive 2. And notice it just zaps to the answer. So our second intersection is at x equals 2.85, y equals 0.15 if I round to two decimal places. So that's how we can use the calculator to help. And then the other way that we said we might need to solve quadratic systems is just through the algebra. How do we do that? We'll go to the forms where we've got the y by itself on one side, and we're going to set those two forms equal to each other. So negative x plus 3 is equal to, now I'm going to use the original up here, negative 2x squared plus 4x plus 5. It's just easier to work with at this stage of the game. Again, I like the x squared to be positive, so let's build the 0 on the right and get everything else over on the left. Be careful on combining those like terms. Now, we know that this is not factorable to solve because these answers are irrational. They're lengthy. Only nice, rational answers can be factored to solve. So we can turn our attention to the quadratic formula. Remember, it's x is equal to negative b, which in this case will be 5, plus or minus the square root of b squared. When you do this, please put it in parentheses. You need the parentheses when it's a negative. B squared minus 4ac, all being divided by 2 times a. And in this case, a was just 2. So we will simplify. So inside of our square root, we get 25 plus 16. 25 plus 16, I believe, is 41 all over 4. Now we do want to continue to simplify this. So we are going to split it into two separate items. It'll be 5 fourths plus or minus the square root of 41 all over 4. Now on the one hand, that means x is equal to 5 fourths plus radical 41 over 4. We'll circle that because that's one of our answers. On the other hand, though, that means that x is equal to 5 fourths minus the square root of 41 all over 4. Now to solve for y, we'll need to plug back into y equals negative x plus 3. So we'll do that for each of these two items. On the left here, y is equal to a negative x plus 3. Now make sure you distribute that negative here. So it'll be a negative 5 fourths minus radical 41 fourths plus 3. Notice that that radical 41 fourths is not something that we can simplify, but we can combine the negative 5 fourths with the 3. 3 is really 12 fourths. 12 minus 5 is 7 fourths. So it should be 7 fourths minus radical 41 over 4. You could verify that on your calculator if you would like, but here's the one combination for x and y. For the other combo, again, we're going to take our value of x and plug it into y is equal to a negative x plus 3. And as we solve that, we still need to distribute our negative. We still need to combine the like terms, which are the 3 and the negative 5 fourths. That's going to be the 7 fourths again. And there's the y value that matches up with our x. Now the final thing that we can do is take our calculator and see if these approximations match our earlier approximations. So here's our one set of approximation. X was 2.85, y was 0.149. Come back here, we're going to type 5/4 plus radical 41 over 4. Close the square root on the 41. Hit enter. Woo, there we go. That x value checks. How about the y? 7/4 minus radical 41 divided by 4. And I think that also checks. If I scoot this calculator over, it was about 0.15. So both of those are good. They work out. Now how about for these other two? Well, remember one other trick we mentioned in class? If you hit second enter, it scrolls through what we've already typed. For the x value, I'm just changing the sign there, making it a negative. We get negative 0.35. Then I'll go second enter, and we're changing this from a negative to a positive. And those are the two values for those, x and y. So let's see if they match up. Do they match up? Well, here's what we had earlier, negative 0.35, 3.35. It works! So this is how you could solve a quadratic system of equations for the exact simplified answers, or you can quickly solve on the calculator for the approximations.